Well, we've got a big topic tonight. We're going to cover sequences and series, specifically arithmetic, geometric, and recursive. So take good notes, and we'll look forward to seeing you in class tomorrow and the example that you'll be doing for us. So what is a sequence? Well, the definition is just an ordered list of numbers. Nothing too tricky. So example 1, we're given this rule. And remember, when you see this lower variable, it's called sub. A sub n equals 2n minus n. And question A says, find the first three terms of the sequence and denote by A1, A2, A3. So all you're going to do is you're going to make yourself a table, and it's very simple. We're just going to say the variable in here, whatever's in my sub, is the variable I'm going to use here. So this is n. And then this is always the rule. So A sub n equals 2n minus n. Okay, and this is very simple. Basically, it wants the first three terms. So my first term is going to be 1. And notice, I'm saying let n equal 1. So I'm going to replace every n with the number 1. And don't do any math in your head, just write down what you get. Equals 2, substitute with parentheses, minus 1. Now I'm going to clean it up on the line below. A1 equals 2 times 1 is 2, minus 1 is 1. So off to the side, a sub 1 equals 1. Then you just do the next term, 2. I'm going to replace every n with the number 2. So a sub 2 equals 2, substitute in a 2, minus 2. Okay, and again, right below, we'll do the math. So I get a sub 2 equals 2 times 2 is 4, minus 2 is 2. And I'll write my answer down off to the side here. And lastly, once the first three terms, so we'll get the third term, 3. I'm going to replace every n with a 3. A sub 3 equals 2, substitute 3 minus 3. And below I'll do the math. 3 times 2 is 6 minus 3 is 3. So a sub 3 equals 3. And that's all they're looking for. It's that simple. Now, part B says, find the sum of the first 10 terms. And to me, the key word is sum. So let's talk about the quick way and the slow way to do it. If it wants me to write an equation using sigma, I would say, I'm going to use my sigma, from n equals 1 to 10. That would give me the first 10 terms, starting with 1, ending at 10. And then I would just put my rule in here, 2n minus n. And then it's very simple. You just start by plugging in the number 1. So 2 times 1 minus 1, which we already did, we said is the number 1. And then you just add the next term, 2 times 2 minus 2, which we already did, and we said that's 2. And we'll just add the next term, 2 times 3 minus 3, which again we already did is 3. And we'll just keep adding each term up. Again, if you have the calculator, you can type that in, that updated calculator. If you have the old calculator, you're just going to go this nice slow method. And again, this sigma means sum, and we would just continuously add each term up. All right, our second topic is recursive sequences. And this time, terms are found by operations on previous terms. So in our first example here of recursive, a sequence is defined by the recursive formula, and it's given. And you'll notice they'll always give you a term in recursive. The question says, generate the first 5 terms of the sequence. Okay, so again, I'm going to start with my table, and the first thing I'm going to say is, what is the variable in the problem? And it looks like the letter n. So I'm going to say that's n, and then I'm going to write my rule down, and you're just copying that rule. A sub n plus 1 equals a sub n plus 5. Okay, and now again, it's very simple. You're just going to ask yourself, what is my first n value going to be? Now notice, a sub 1 is equal to negative 2. So I'm going to label that over here. A1 equals negative 2. Now ask yourself, what did I plug into n if I've got a sub 1? Did you plug a 1 into n? Well, if you replace n with 1, what is that going to get you here? A sub 2. What number must you have plugged into n to get a sub 1? Hopefully you're saying n was 0. So again, I'm going to replace all of my n's with 0. Okay, I'm not doing any mental math. I'm replacing every n with 0. And when I do that, I get a sub 1 equals a sub 0 plus 5. Now, you can obviously figure out what a sub 0 is. I don't really care. I already told me that a sub 1 equals negative 2, so I'm just going to go with it. But the key was to understand that n was equal to 0. So the next number I'm going to plug in, of course, is 1. So I'm just going to go through and replace every n with the number 1. Again, don't do any mental math, just write it out. So that becomes 1 plus 1 equals a sub 1 plus 5. Now underneath you can do the math. This becomes a sub 1 plus 1 is 2 equals a sub 1. I'm just going to box that in. What do you know about a sub 1? Well, I'm going to use my previous term, negative 2 plus 5. So I can officially say a sub 2 is equal to 3. Okay, then I'll plug my next n in. That was 0, that was 1, the next n is 2. So I'm going to replace every n with the number 2. A sub 2 plus 1 equals a sub 2 plus 5. Okay, then underneath I do the math. That's really a sub 3 equals a sub 2 is the previous term. 3 plus 5, which is 8. So a sub 3 equals 8. Notice how I answer each term at the end with its a sub and what it's equal to. And if I scroll back up real quickly, it said what are the first 5 terms. So why don't I pause it, you pause it, and see if we get the next terms correctly. And hopefully yours matched with mine. I've got my first 5 terms written out, 2, 3, 8, 13, and 18. Okay, so recursive again is using the one previous to it, and just be careful what n equals when you start off. That's the only trick. What did n equal for me to get this term? So next example, again it's recursive again, and I know that because they give me terms to begin with. And the question says find the first 6 terms. So let me start you off one last time. I'm going to look here to see what the variable in the problem is, and it happens to be an n again, so that's my first column. Okay, the rule is always second, write the whole rule out. A sub n plus 1 equals a sub n plus a sub n minus 1. Okay, and now you'll notice they give you 2 terms. They told me a sub 1 is equal to 1, a sub 2 is equal to 1. And notice I need the first 6, so I already have 2 of them done. Now, this rule works when you plugged what number into n. Well, what would n have to be in order for you to get a sub 1? Hopefully you're saying n is 0. And what number would you plug into n so you got a sub 2? Well, if you wanted this to turn into a 2, then n would have to be 1. So hopefully you're saying the next logical number to find is a sub 2. And again, I'll do one row with you, then you're on your own. I'm going to replace every n with the number 2. So I've got a sub 2 plus 1. Again, I'm not doing any mental math, just write it down. A sub 2 plus a sub 2 minus 1. Second line is where the math comes in. This turns into a sub 3. Okay, then it says take a sub 2, and we know that as 1, plus a sub 2 minus 1 is really a sub 1, so I can replace that with 1. So I get a sub 3 is equal to 2. All right, we need the first 6 terms. I'm going to pause it, you're going to pause it again, and see if we get the same thing. Don't cheat yourself. This is our time for review. All right, so let me start fresh, and again, hopefully you can scroll through and see if yours matches up. I've got my a sub 4, and notice these take time. I'm writing each step out so I don't make any mistakes. I've got my a sub 5 and a sub 6, and again, hopefully you agree with all of that. All right, so our rule for arithmetic sequences. Arithmetic sequences. Now, arithmetic sounds like the word arithmetic, so hopefully you're thinking add. There has to be a plus sign someplace. So it just starts with a sub n equals a sub 1, which again is the first term. And there's that arithmetic, add, d is the difference between the terms, times the quantity n minus 1. So you always want to know the first term and the difference, and you should be in good shape. All right, example 1. Find the common difference for this arithmetic sequence. So all your goal is to say arithmetic. Okay, they gave it away. We're looking for adding, technically, or subtracting. And I'm just going to look between the two terms. How did I go from 5 to 9? Well, hopefully you're saying that's a difference of positive 4. From 9 to 13, positive 4, 13 to 17, positive 4. So therefore it's arithmetic since every term is being added by the same amount. So you just start with the general rule. So basically they did just say what's the common difference. I would say my difference is 4. And now let's put it all together. A sub n equals a sub 1 plus the difference times n minus 1. Okay, so a sub n equals a sub 1 is my first term plus my difference of 4 times n minus 1. And then we'll just clean it up. Let's see. Distribute my 4 there, so 5 plus 4n minus 4. Throw my like terms together, and my rule is 4n plus 1. So something to pick out in this formula, if I just gave you this equation, could you easily tell me the common difference? So let's just make a note. When it's linear like this, our common difference is basically the slope of this line. Okay, so if they just give me the equation, you should be able to tell me that the common difference is 4 because it is the slope of this function. Next example, find the 10th term of this sequence. So again, my first job is to write the rule before I can find the 10th term. So again, I would quickly just say, how am I getting from each term to each term? 3 to 5 is a plus 2, 5 to 7 is a plus 2, 7 to 9 is a plus 2. So I would say that's arithmetic by plus 2. Why don't you pause it, write the rule on your own. So hopefully you can follow my work nice and easy. I had a common difference of 2, first term was 3, and there's my rule. Now if I want the 10th term, that just tells me to replace every n with the number 10. So a sub n equals 2 times 10 plus 1. A sub 10 is equal to 21. And there you have it. My next example says find the sum of the first 5 terms of the sequence. Okay, so again, sum is telling me straight sigma notation. First 5 terms, I'm going to let n equal 1 to 5. And then I just need to find the rule. So again, ask yourself, what's happening between each one? How do I go from 2 to negative 1? Well, I would say I would subtract 3. Negative 1 to 4, subtract 3. Negative 4 to 7, subtract 3. So pause it and go ahead and write the rule. So if you follow my work off to the side there, I've got negative 3n plus 5, and I just want to recall the slope should tell me the difference, and negative 3 was the difference, and I'm just going to throw that in my sum formula, negative 3n plus 5. And then again, to find the sum, I would plug in the 1, add that, plug in the 2, plug in the 3, 4, and 5, and you've got your final answer. And I'll let you do that on your own. Our last little topic is geometric sequence. This time, we want to multiply. So you'll notice my formula this time is a sub 1 times the ratio to the n minus 1. And again, this is my first term, and the ratio is what I'm multiplying by. So not the prettiest one to begin with, but it says find the common ratio, so that's a dead giveaway that I'm looking to multiply something. So I think the first one's the easiest. How do I go from 6 to negative 3? What do I multiply by 6 to get negative 3 as an answer? Well, clearly it's a negative number, and you might be thinking take half of it, which is really multiplying by half. So I would say if I multiply by half, I get negative 3. Let's take that and multiply by a half. What do I get there? Well, remember, this negative 3 is over 1, so I would get a positive 3 halves. Is that formula matching up? I would say so. So, now that we have the ratio, let's get that rule down. A sub 1 ratio raised to the n minus 1. So my first term was 6 times ratio of negative 1/2 to the n minus 1. And I want you to box that in, and just be clear that you cannot multiply those together. The n minus 1 is strictly on the negative 1/2. So you cannot multiply that and say negative 3. This is your final answer. Number 2, find the common ratio for the sequence just by looking at the formula. So I just want to recall. So if I just match them up, the a sub 1 is 5, so that should be the first term in the sequence. And the ratio is 3. That means I'm multiplying by 3. So it said, what is the common ratio? 3 is my answer. And if I had to list the sequence, I could really just sit here and multiply by 3. So my next term would be 15. If I multiply by 3, 45, etc. All right, last one for the night. Find the 7th term of the sequence, and we'll be looking for this in your notebook tomorrow. Have a great night.